Hello everyone. On behalf of Team Current Affairs Review, I Anthony welcome you all to the discussion. As in our last discussion, we have analyzed the dynamics of extratropical cyclones and anticyclones and how they traverse with varying regularity with the prevailing westerly winds. And we have also discussed the theories related to it. By the way, if you have missed the last discussion, you can get the link which is given in the description box, or you can visit our channel as well. So today we will move little further on understanding the tropical atmosphere, where it acts as a heat sink of the radiant energy, which is obtained through the short wave solar radiation. And with the high rate of heat exchange between oceans and atmosphere, they bring considerable amount of disturbances. By this, it is quite clear that in today's discussion, we will put emphasis on tropical cyclones and its dynamics. So we will segregate the discussion into three parts. Firstly, the genesis or origin of the cyclones. Secondly, the structure, and lastly, the regional disturbances. And also a small overview on the tornadoes as well. So let us start our discussion with the tropical cyclones and its origin. A hurricane or a tropical cyclone is similar to a heat engine that is powered by the latent heat of condensation. Although the specific mechanism that causes the tropical cyclones to arise, it is not well known at this time. However, there are some basic characteristics that must be met in order for a hurricane to form. Tropical cyclones of hurricane strength develop over a warm tropical waters where the surface temperature is around 27 degrees centigrade and allows water vapor to fill the lower layers of air next to the ocean surface. In the process of cloud and rain production, the latent heat is transferred into storms and released. Another fact is that the tropical storms rarely form within the 5 degree and 8 degree wide belt on both sides of the equator, and it suggests that the Coriolis force is important in cyclonic air circulation. But the majority of the cyclones are restricted in the belt spanning 5 degrees and 20 degree latitudes, with the highest frequency occurring around between the latitudes of 10 degree to 15 degree. Also, due pre-existing mild tropical disturbances increase and evolve into the hurricanes or strong tropical storms under favorable conditions. And these minor differences in water and air temperature produce a number of small lower pressure centers, which brings a weak cyclonic circulation. Furthermore, there must be an anticyclonic circulation at the height of 9,000 to 15,000 meters above the surface disturbances in order for ascending air currents within the cyclone to continue to be pumped onto it in order to maintain the low pressure at the cyclone center. Another fact is that in the tropical intertropical convergence zone, there are small atmospheric vortices that get formed. It's worth noting that the tropical winds with both hemispheres meet along a line known as intertropical front. When the intertropical convergence zone is farthest from the equator, the temperature disparities between these air masses must occur. As a result, the convergence of this different in temperature winds as well as the resulting instability cause tropical disturbances. Although this analysis are based on the meteorological observation, yet substantial data and analysis is still missing on determining the components of development of tropical cyclones due to the paucity of the observation stations in these areas. If more surface observation stations are made available, the unresolved questions about the tropical cyclones may be answered. Now we have come to the second part of our discussion, that is the structure of the tropical cyclones. In the recent progress on analyzing the tropical cyclones, it is found that three main components influence the tropical cyclones. Firstly, the eye. It is a relatively calm center which often have a clear patch of sinking air with low winds that rarely exceed to 24 km per hour. But what causes an eye to form? It's most likely due to the interaction of the angular momentum conservation and centrifugal force. The conservation of the angular momentum states that when objects travel closer to the center of circulation, they will spin faster, and as a result, air speeds up as it approaches the tropical cyclone's core. There is a pull outward when the wind rotates around the tropical cyclone center, which results the centrifugal force to be stronger when the curvature is steeper and the rotation is faster. The intense rotation of air around the cyclone balances the inflow to the center, causing air to ascend from the center, generating the eye wall. Now the eye wall. The eye wall is made up of ring of tall thunderstorms that provide the heavy rain and fearless winds. Wind speed, which is an indicator of the storm strength, can alter due to the changes in eye and eye wall structure. Double concentric eye walls can form as the eye grows or shrinks in size. And lastly, the rain bands. These curved rain bands of clouds and thunderstorm that trail away from the eye wall moves into spiral fashion. These bands have the potential to produce tornadoes as well as significant rain and wind bursts. There are some instances where when there are gaps between spiral rain bands and where there is no rain or wind. So now we will discuss the regional distribution of the tropical cyclones. Tropical cyclones, according to some weather scientists, migrate from east to west, following the basic currents of trade winds and equatorial westerlies. These storms steadily gain speed as they migrate away from the equator. The tropical storms always follow certain courses because the warm ocean currents most likely influence the cyclone's path to a considerable extent. The tropical cyclones curve toward the poles after reaching the western section of the tropical oceans. And under the influence of the upper westerlies, some storms curve strongly poleward between 20 and 30 degrees north latitude, then recurve towards the east. The tropical cyclones in the tropics do not have any fronts. They are dragged into eastward or northeastward, moving extratropical cyclones after leaving the tropics and develop different fronts and air masses in the mid-latitude regions. When a tropical cyclone hits a land, it loses a lot of its strength because its source of moisture is cut off. In other words, there isn't enough energy on land to keep the cyclone going. Increased friction is also contributing to the hurricane's weakening over land, and as a result, it is apparent that the tropical cyclones form over the waters and then dissipate over the land. The path of the tropical cyclones across the North Indian Ocean differs from what has been documented about the general movement of such storms in other regions. These storms are superimposed on the monsoon circulation of the summer months, and they migrate northward with the monsoon currents. Now we have come to the small overview on tornadoes. In contrast with the cyclones, a tornado is a violently rotating column of air accompanied by a funnel-shaped or tubular clouds that extends downward from a cumulonimbus cloud. Although tornadoes are localized in nature, they are the most dangerous storms on the planet. They are modest in size and have a brief lifespan. These atmospheric disturbances may be among the most destructive forces in nature. These small-scale severe storms have a diameter of 150 to 600 meters, and storms are expected to travel at a speed of 30 to 45 kilometers per hour across the land. Tornadoes can occur anywhere on the planet, with the exception of the severely cold northern areas of continents during the winter and polar regions. In United States of America and Australia, they are quite common. Because of their small size and complex development process, forecasting and issuing warning for the storms is extremely challenging. But recently, forecasting tornadoes and detecting them and disseminating the warning to the public have all improved dramatically. It is now possible to predict the timing and location of their onset. Once the storms have formed, the radar storm detection technologies can track them closely. So this is the end of our discussion. We will move further in the next video, where we will discuss the dynamic nature of tropical cyclones in the Indian subcontinent and why the intensification and frequency are increasing over the Indian Ocean and what is the impact to it. So if you like the video, kindly like and subscribe our channel, and also you can visit our platform currenteventsreview.com and avail the PDF of the today's discussion. So thank you for watching guys. Have a nice day.